Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion is part 20 of an ongoing series dealing with Operating System Deployment feature of Configuration Manager 2012. Today's discussion specifically focusing on some automation and customization type scenarios that you can do with OSD. So, big topic, a lot of different directions we can take this thing. Really just want to try to scratch the surface of this a bit and do some demonstrations, maybe get some thinking started about what's possible, and so on. So that said, here's the agenda that I want to approach. Talking about what I call beyond the GUI, whether we use the GUI, whether we use standard steps, that kind of thing. Hit on PowerShell, some of the things we can do there. The idea of parent and child task sequences, with the task sequences in quotes there. The concept of providing imaging as a service. Wrap up with a discussion that we've probably mentioned before in this series. I can't remember, but it's called the sweet spot of imaging. We'll talk about that in a minute. So it's kind of a building approach, actually. So if you look at this, the most complex one of these is down here that has a couple of layers on it. But either way, we'll get there. So beyond the GUI. Right, so we've talked a lot in this series about task sequences, about the steps that are in task sequences, about how task sequences run, and the phases, and Windows PE, and the Windows OS, and different things. Right. So there comes a point at which, as we get more advanced, the question might come up: should I use an inbuilt task sequence step versus trying to do something totally custom? And I've seen it work both ways. Certainly OSD is very powerful, provides you the building blocks you need to do very sophisticated imaging, but sometimes you can actually get into scenarios that we don't exactly address with our inbuilt task sequence steps, or maybe it's more efficient for a given scenario to kind of build your own, right? So don't do that as a first blush, for sure, because you do want to have a good amount of experience with task sequencing before you possibly go down that route. But it is a valid question to ask at some point. So do we go custom or do we use default? So as a way to kind of illustrate that, I want to pull in the lab and show a couple of demos that I have here, or at least one demo that I have here. So I've got just a standard Windows 8.1 task sequence deploying Windows 8.1, and you'll see that I have mostly the default steps in here, and that's cool, right? So one of the first questions that comes up is, what kind of steps might I consider valid, or might be considered valid for full customization? What kind of steps maybe should we stay away from, right? And the answer is, you could build all of this by yourself. We've already talked about how to use DISM. We've talked about how to capture WIMs and apply WIMs without task sequencing and different things. Point is it worth the effort, right? And so whenever I ask that question, a couple of steps come to mind. One is just the apply OS image task sequence step right down here, right? Certainly you could do this and use DISM and different things, but in a lot of these steps, there's things that are happening behind the scenes that may not be obvious just by the name of the step. Certainly this is one, right? There's all sorts of things that we can do with the unattend file and the sysprep answer file and different things. Frankly, things that you could do yourself, right? But there are complexities that makes it lend itself to using what we have inbuilt. There's other steps in here that might make sense just to do your own thing in some cases, right? So this is just applying a data WIM, taking a WIM and dropping it onto a disk that you've provisioned, but you don't expect to have it bootable, that kind of thing. You could do that. You could use our step. We provide you a lot of flexibility in here to use our step quite effectively without having to bake your own, and that's cool. And then the last one that I'll talk about is this one, Set up Windows and Config Manager. This is one that if you've ever paid attention to imaging, it's not a short-term process to work through this step. In fact, there's a reboot in the middle of it and different things, right? It doesn't just install the Config Manager client. There's a lot of behind-the-scenes work and manipulating, saving data to the disk before the reboot and triggering the reboot, and on we go. So this is one. Doesn't make a ton of sense to try to customize. Probably wouldn't get it right anyway if you tried, right? But there are some pieces that it does make sense in some scenarios to customize, and one of them is partitioning and formatting the hard disk, right? So we certainly give you great flexibility in terms of partitioning and formatting the hard disk. You see the inbuilt steps there to be able to handle that. In this case, I've got them grayed out because I'm not going to use them, but great flexibility to be able to pick the disk, partition it the way you want, so on. But what about the scenario where you might have 5 or 6 different types of hardware that you want to build? All of them have maybe different disk sizes, and based on corporate needs or business needs, you want to carve up different partition sizes based on the size of the disk, right? Well, you can certainly do that in one of these inbuilt steps. You could just do a detection. You could add a condition to look in WMI and learn what the size of the disk is, and if it's a certain size, then you could run a step to partition it the way you want to. At the end of the day, you might have 7 or 8 steps in a task sequence, and you only execute one of them based on logic, right? That's doable, and I would not discourage that. It's a very good way, very effective way to be able to do this. But at the same time, it could be that maybe you want to just have one step and kind of grow this on your own, and that's what I've done here. So you see, again, I've got my default steps for partitioning grayed out, right? They're not there. And I'm actually going to do partitioning myself. And so let's walk through that. Specifically, there's 3 steps that I want to do, and that one's grayed out too. That's just one I was using for test. There's 3 steps I want to do in order to enable me to run a PowerShell script. One is I'm just going to map a drive. You could do this a couple of different ways. I'm doing it this way because it's convenient. I'm mapping a drive to where my PowerShell script is going to be located. Then I'm going to run that PowerShell script. Now you notice I'm using a run command line option here to call that PowerShell script from the command line. You don't have to do that. You could use the inbuilt PowerShell script here, run PowerShell script command, put it in a package and that kind of thing. Just didn't want to have to worry about that for my example, but it's certainly possible. And then that process, there's a little bit of time. It's not huge, but a little bit of time that it takes to run this thing. So I want to make sure the task sequence pauses before it moves on to the add operating system or apply operating system, because if the disks are not ready, then this step will fail because there's no place to load the operating system. So I'm just putting in a sleep command for 15 seconds. Once the script runs, I'm pausing an additional 15 seconds to make sure it's all ready, and off we go. Right? This is what I'm using for partitioning. Now, the script itself that's handling the partitioning, let's go look at that. So here is that script. This is very simple, but hopefully gives some ideas. So the first thing I'm doing is I'm going to query the Win32 disk drive object stored into a variable, right? And then I'm going to, and you may have more than one disk, and if so, you'll need more logic than this in the script, and that's cool. It's easily done, but I just have one. So then I'm just checking if the size is less than this value, then I want to write out a certain kind of disk partitioning script. If it's greater than this value, then I'm going to write out another one. The only thing that's different between these two sections is here. In fact, I probably could be more efficient. I know I could, by writing the disk part components, just having one section that writes the disk part components, and then have a difference here for the delta. Whatever, I just put this together quickly. You can do it, whatever makes sense. And then once you have it written out, just start the process, call diskpart, and pass in the script. So I'm going to store the script on the X drive, the WinPE disk that's created. Right. So this is easy. It handles really either it's this, less than this, or it's greater than this, and so on. It could be that you have more logic you need to handle than this. Maybe it is. Probably it is. Right? But at least it illustrates the concept. So that said, let's actually go watch it run. So I'm going to pull in one of my machines here. This is just a bare metal machine that I'll pull in. It's actually got a small disk partition, small meaning it's going to fall into that first condition. So I'm going to boot from that DVD and let it go do its thing. All right, so we've got that up and going. So I'm just going to step through, pick the task sequence that I want. It's going to be the custom one. Off we go. You'll see that Windows PE pops up, and I'm sorry, the DOS window pops up, and then we run the step to run diskpart like we see right now. So the disk is being partitioned, and we're good. So we'll let it finish up here, and then we'll move on to the next part of this discussion. Cool. So now the partitioning's done. Now I'm into the wait step for the 15 seconds, and then we'll go on and finish up and start to apply OS. So here we go. We're applying the operating system, and we're good. All right, cool. So I will close out of this and close out of this, pull the lab back out, and we'll go on. All right, good enough. So PowerShell. It's kind of hard to get into any real discussion about automation without getting into a discussion of PowerShell. And so there's kind of some questions about what really can you do with PowerShell, with automation of ConfigMgr imaging and such. And the answer is there's really a couple of places where this comes into play. Right? So we've talked about, if you reflect back on session 15 in this series, we did talk about an example of using PowerShell inside Windows PE during imaging, and then we didn't talk about an example of it, but there's also the concept of using PowerShell in the imaging process whenever you're inside the running operating system. And the options are different between both, right? So in Windows PE, so in either case, during imaging, during the image deployment process, in either case, you do not have the specific ConfigMgr commandlets available to you locally. Locally is key. In Windows PE, you're limited also because some of the more advanced, at least at the time of this recording, some of the more advanced remoting capabilities in PowerShell are not workable in Windows PE version of PowerShell. And so you're left with some of the legacy remoting opportunities that would work on such commandlets like a get WMI object and specifying the computer name and so on. You can still do plenty of things that you need to get done with that type of PowerShell remoting, but it's just a little bit more challenging to write the PowerShell because you don't have some commandlets that would make it easier, right? So why would you need to do remoting in Windows PE? So if you'll recall back in that example, while we were in Windows PE in that example, we were wanting to connect with the ConfigMgr server and add variables and maybe move machines around in collections and so on. Things that you would want to do prior to a task sequence starting. So in the case of the example, it was a pre-start command, which happens in PE. Could be some other things you want to do in PE phase of imaging. Point is, you're not going to be able to leverage the ConfigMgr commandlets for specifically OSD in that phase of imaging. Once you get past PE and boot into Windows, then it would be possible to use the more advanced style remoting. Probably still don't want to take the time to import the module for ConfigMgr that gives you direct access to these commandlets, but you can certainly use remoting to load that module on the ConfigMgr server side and make use of it, right, to do whatever you need to get done. So that's why I said you're not going to have it locally, even in a running Windows, whenever you're imaging, but you can certainly leverage it with PowerShell remoting. So what would you want to do maybe during the Windows phase of imaging? Well, one very clear example would be perhaps at the end of the task sequence you want to programmatically remove the system that just completed imaging from the collection. Very common thing, fairly common thing, right, that you can use with PowerShell remoting and using some of these commandlets down here. Remove CM, there's no CM device. Well, this is just all the OSD stuff, but there is an equivalent. Remove CM device from collection, I think is what it's called. All right. So that's during the imaging process. But and these are the commandlets that I pulled out just quickly, probably missed some, that are specifically related to imaging, the imaging process. Some of it you may not want to do during imaging. Some of these things you may want to do external to imaging, which raises the third question. What kind of imaging operations would be imaging-related commandlet type operations would be interesting outside of a true imaging process? So that gets into a discussion of some things that we've talked about before, and then an example of some new things. So the thing that we've talked about before in this series is, and I won't even pull it up here just to show it, is the idea of a web page, right? So keep this one in mind as we move along and talk about the imaging as a service topic here in just a minute. But the concept here is that we would build a web page or a SharePoint form or an HTA or something like that that would give the ability for users or for field technicians or for even OSD administrators to have an interface that is not the Configuration Manager console to go and configure imaging options. The web page in this case would present the full array of imaging options that you want to allow in your organization, and then users can pick and choose what they need accordingly. Or maybe you put some defaults in there based on the particular business group of users in, whatever, right? The sky's the limit. You're designing it yourself. And then the commandlets, the Config Manager commandlets, PowerShell, could be very easily and effectively used to pass variables, for example, to a computer object or a collection object to dictate how the flow of imaging will work for the system being configured. Right? You'll actually see the OSD webpage here in a bit and such. It's actually built, the one in the example I will show is built on VB. If I were to build it today, I would use PowerShell, hands down. Right? All right, what else might you want to do? Well, I could go on and on and on with the examples, but another example might be manipulating your boot image. So let me pull that example in just a minute. So here's just an example of a script that I borrowed from one of my colleagues, Frank Rojas, who very much active in the imaging community, wrote to manipulate a boot image. Right? In this case, it's a Windows 10 boot image, and there's some reasons why with the specific scenario that he wrote this up. But the point is, you can do these kinds of things, right? You can easily connect it to the WMI namespace, call the SMS boot image method, go and create some WIM files, rename it to WIM files, whatever it takes, generate the boot image calling this method, and so on, export the boot image, whatever, right? So may not ever need a script like this, but at least it's an example of things you can do with PowerShell. Notice that I'm not even really using any specific Config Manager commandlets here, but it's just generic PowerShell being used and brought to bear against a specific need to make it easier and more automated, right? And again, we could go on and on about the options here, but those are a couple to suffice, right? All right. So the concept here, just to illustrate of the idea anyway, of parent and child task sequences. Well, you can tell from the demos that I have here, there really is no such thing as a parent and child task sequence. But the concept is interesting. It's solid, right? So this is the automation concept that will pull in something like Orchestrator. So maybe you have a task sequence, could be imaging, might not be imaging task sequence. You're going to see me use examples in a minute of non-imaging task sequences just for convenience, where there's a portion of time in the task sequence that you would like to spin off a particular function to Orchestrator. Maybe, whatever it is, sky's the limit. Maybe it's adjusting something in AD. Maybe it's making sure a particular setting is correct on a domain controller before you move on. Whatever it is, right? Something that's better suited for Orchestrator than a task sequence. You could maybe do it in the task sequence, but it might be more appropriate to call into an Orchestrator server that is closer to wherever you're doing the action, whatever it is, right? There are scenarios for it. And then once that Orchestrator runbook finishes up, you want the task sequence to resume. Or you may just want the task sequence to hand off and just keep running anyway, right? Whatever the scenario is, that's what we're trying to illustrate. And so the best way to talk about it is really to just show what it is that I'm talking about. So let me pull in my other lab where I have Orchestrator and walk through or talk through this by way of demo. So I've actually got two demo scenarios. I'm not going to do the third just because it gets a bit redundant. But the third is certainly a workable option where Orchestrator calls in and initiates maybe a task sequence or whatever. But we'll start here. So this is a task sequence that will call Orchestrator and then we'll finish up. So let me go edit this thing. So this is really simple. I know that these examples are very basic, but I hope they illustrate the point. So what I'm going to do is use the MDT execute runbook step. You don't have to use the MDT option if for some reason you don't want to. It's actually a very nice option, but you could use something like the web service in Orchestrator. You could use SCO Job Runner, which is on Codeplex, or whatever, right? This is what I chose here. In order to use this, I have to first load in the toolkit package, make sure those files are downloaded so that certain scripts are available and ready for use as a part of this process. So that will take just a little bit of time to download, and then this will run. And then basically I'm handing off and telling Orchestrator, hey, go run this thing called new runbook. So if I browse, just to show you on the Orchestrator server, this is the folder where my runbook is located, and this is called new runbook. So that's what I chose here. No parameters, although you could certainly specify parameters and pass them over if you had them or whatever. And then notice this last option, wait for the runbook to finish before continuing. So this is an interesting choice. Really what this choice is to say to the task sequence, all right, I'm going to spin off to Orchestrator, and I want Orchestrator to finish and complete prior to continuing to process the task sequence, and that's fine. But what if the task sequence completes and doesn't actually get the job done that you were asking the task? I'm sorry, what if the runbook completes and doesn't actually get the job done that you were hoping the runbook would get done, right? Simply setting this flag to wait doesn't guarantee an outcome. So what I prefer to do is actually control what is going to happen based on output from the runbook. So in my case, it's really simple. I'll show it to you in just a minute. But think about a runbook. You could actually have multiple branches inside a runbook and returning different results, maybe registry entries or flag files or whatever, or text inside a flag file, based on the experience the runbook has had. Maybe it's a failure, maybe it's a problem, maybe it's a success, right? In my case, it's really simple. It's going to be a success. And then you could actually have logic in your task sequence that would respond accordingly, right? So in this case, I'm just handing off to the runbook. Runbook is going to start. So let's go over to the runbook server, or the Scorch server. And here it is. Very, very easy, right? All this is going to do is try to start a service, and then once it's done, it's going to write a file called tsorc.ts.txt. And that is going to be the indicator that the runbook has finished, right? Again, if I wanted to, I could put in logic here to write a certain flag file if it finished successfully, write a certain flag file if it finished with a problem condition, write a certain flag file to describe the process along the way, whatever. The sky really is the limit. It's up to you how you design this thing. The one thing I want to make sure of is that my flag file is not here, because I think it is. Yep, it is. So I'll delete this. And then we'll run the process. So once the runbook executes, so remember the task sequence is not waiting on the runbook to finish. I did not select that box. So while I call out to the runbook, the task sequence is moving on. I have to be, if I don't set that box to wait for the runbook, I have to be in charge of handling that. And so I do. And so right after the runbook gets kicked off, I'm mapping a folder just for convenience. This is on my Scorch server, because this is where that file should show up whenever the runbook is done. And then I simply launch a PowerShell script. It's not in a package. It's just on the root of my C drive. I just launch a PowerShell script that's going to have the job of monitoring. Right? Again, very, very simple, nothing complex here, although it could be fairly complex in production environment scenarios, but not here. Font's too big for some reason. Shrink this down. But the point of this really is that this is going to sit here in a loop, and it's going to pause 1 second every time it loops, and it's just going to keep checking this directory to see if this file has ever shown up. Right? Once it does, then I move on, and the task sequence step completes, and I'm good. Right? So it goes without saying, again, that this is simple. It also goes without saying that there would need to be logical controls probably put in this, much more than what I'm doing right now, and probably some timeout so that you don't just sit here and get into a loop and so on. But, again, the point here is just to illustrate the concept. So that said, let me go ahead and run this. So I actually have just a server here that I've already run these successfully on, but I'll run it. Here's the particular one that I've deployed. It's task sequence handing to orchestrator, handing back to the task sequence. And I'm going to initiate this. Runs pretty quickly. I mean, pretty straightforwardly. It does take a minute to run just because it has to download the MDT toolkit and so on. And then it's going to kick off from there. But we'll just watch it for a second. So it's setting that up. Then it will hand off to Orchestrator. And let me, if I can be fast enough, let me see if I can. Should have had this before. Yeah. So we'll monitor for that file to show up, the flag file. So it's just about, should be just about to kick off the runbook. And then we'll see the flag file, and then we'll see the PowerShell script detect the flag file, and then it's all done. There we go. Executing runbook. Runbook is running. PowerShell script is running. That flag file did show up. It just took a minute for it to refresh, but it was all very quick once it got going. All right. So I'll delete this again. So the next example is also equally simple. It's right here. Task sequence calling Orchestrator, except this time Orchestrator hands off to a child runbook of its own, and then it hands back to the task sequence. This is exactly the same scenario, but let me show you the difference in construction. So in terms of the task sequence, there is zero difference. It's the exact same task sequence, right? The only difference is which runbook I'm calling. So in this case, I'm calling a master runbook, but the rest of this is identical. It's looking for that same flag file, running that same PowerShell script, and so on. So if I go to my Orchestrator server and go down to this runbook, I have a master runbook. Again, very easy. All this does is it kicks off and uses the invoke runbook command to call a child runbook, which is right here. Okay? And now all of the work that I care about is in the child runbook. So we'll run through this. Once it's done, we hand back control to master. Since there's nothing else to do, we end. Right? But it's the concept that I'm trying to illustrate, which is you can build just like you would in code, you can build a master runbook that would then call child runbooks, much like you would have modular code, and be able to do things that way, right? Orchestrator allows you to do the same thing. So pretty simple concept. We'll run through this real quick and show the example. If I can get there, we go up here. So same exact kind of thing. Hopefully this one might run a little bit quicker. Maybe not, but we'll see. Letting it run, downloading, and off we go. All right, give it a second. Just monitor it for a minute, and then we'll, be done. Hang on a second. While this is running, I'm actually looking for something in my system tray. So I can, okay. There we go. That's what I was looking for. All right. So that ran and is done, and it did the exact same thing, and that kind of wraps up what I was trying to show with this particular demo. So hopefully illustrates the concept. Let me pull the lab back out. All right. And this one again, it gets a bit redundant to just watch some demos like that, so I'll move on. But all right, so the next ones really don't have demos here. I mean, I will show you a couple of things, but the really discussion topics as we kind of run this down and wrap up a bit. So one of the things that you can really get to, we've talked again about imaging and how it works and all of these things. What the nirvana really could be of this is if we could get to the point where we deliver imaging basically as a service. So in the world today, we hear all about different items as a service, such as in Azure we have software as a service, we have infrastructure as a service, we have platform as a service, all of those things. The point is, we're in Azure and other kind of competitors in that arena, we're providing a service that people can leverage to get the work done that they need to get done without having to worry about the infrastructure. Well, in a similar kind of mindset, we could handle imaging as a service. And the idea there would be we simply just provide the infrastructure to allow teams around your business to do the job of imaging they need to do while leveraging the infrastructure that's been built. And so this is where I'll return to that web page example. So let me pull that up for a minute on my blog. This again is kind of a little bit of a legacy. It is legacy at this point example, but it's illustrative of the issue. So the idea would be that we build a web page or an HTA or a SharePoint form or whatever you choose that has the different options available for imaging. And you control what they are. You control what populates in these drop-down boxes, all these kinds of things. So you establish the framework. But now it's just essentially self-service imaging. It's a tool that field technicians can use, your own team can use, and whatever. And what this is doing is it's taking the input and plugging it into ConfigMgr where it's needed in order to get the job of imaging done, right? And so if you scroll down a little bit on here, and you see this is VB code, scroll down a little bit on here, basically we're taking all the input, converting it into variables, which is one way to do it, and then the task sequence itself is very generic and works based on the input provided in that web page. So it could be that you have 5 machines that you're imaging, every single one of them run by the same exact task sequence, but every single one of them are built differently because the input given to the task sequence is different, right? Now that's very powerful whenever you can get to that level of sophistication. Doesn't happen overnight, takes a while to get there, but once you can realize it, the results are pretty awesome, right? All right, so that's one way to do it. And there are other ways. MDT has some really cool solutions to be able to have configuration database as an example, or use custom settings INI, or use some of the UDI, user-driven initiative type stuff, which kind of gets away from the zero-touch power that you're probably wanting, but still, you can do those things, right? All right, and then the final discussion. So this kind of is the pinnacle of building all of them. And again, we've kind of talked about it before. It's something that I've had on my blog for a little bit, but it still continues to serve the point of illustrating. And that's the idea that after we've done all the work of building this really cool imaging solution, very often it's viewed as only being applicable to physical hardware, and certainly is. And then when we have virtualized systems, that's kind of seen as being built by VMware templates or Hyper-V templates or VMM templates, if you will, right? And certainly that works. And if you are sophisticated with your template build out, you can do some pretty cool things. Generally speaking, what templates are used to do is build a system and then hand it off. Most of the scenarios that I run into, it's that simple. And so if you separate your physical and virtual imaging needs, then you're essentially going to be building very likely duplication of effort in your processes. You'll also be taking about a 30-year reverse in time in terms of imaging, because using templates largely is very similar to a process we used to use very frequently called Ghost, right? Where we just put everything in the image and then we just keep laying that out over and over and over again. Well, if you spent the time to build a really cool solution for physical, why not apply it to both and let automation handle which one is going which way? And so that's why I put this particular blog entry together. I call it the sweet spot of imaging. The real magic happens down here, and this is very, very basic. You would want to build it out more so if you were going to use something like this in production, but the idea is you maybe have that front page, that HTA, that web page or whatever, where folks can put in whether they're imaging virtual, imaging physical, or what the parameters are for imaging. And then once that's submitted, it might feed into something like Service Manager or feed directly into Orchestrator or however you do it. But at the end of the day, Orchestrator picks it all up and begins to work through the choices. And this right here, for example, is the decision place. If it's physical, it runs this way. If it's virtual, it runs this way, carves out a place on your host, and then it comes back together and the imaging process just starts completely automated. The result is that the work that you've done, again for physical, very easily applies in virtual as well. And one of the places where, and oftentimes, maybe you think of servers as being this kind of solution. Doesn't have to just be servers. Think of VDI, virtual device infrastructure kind of arrangements. Those are workstations. And so depending on the kind of VDI and the needs, this could be a very elegant solution there as well, right? So that's why I present it last, just kind of the pinnacle of the sophistication you can get to if you go down this automation pathway and really know your imaging process very, very well. So that said, we'll wrap up this session, and we have a couple more to finish out the series, so we will see you next time.